Hello friends, myself R.D. Mahajan presenting my new video or part 2 video for nth derivative of standard results. If y is equal to sine of ax plus b, then nth derivative of that term sine ax plus b as a raised to n sine of ax plus b plus n times pi by 2. And therefore to obtain this result, proof of that result, let's consider y as sine of ax plus b it is function of x, b is constant term, a is also constant term. Then differentiating it with respect to x first time, derivative of sine is cos ax plus b. Applying chain rule, differentiation of this term is a. Before finding second derivative, we try to convert this in terms of sine by applying the standard result from trigonometry. Cos theta we know that as sine of theta plus pi by 2 or pi by 2 plus theta. Therefore, this cos I have written as sine pi by 2 plus theta. Theta is here x plus b. And then differentiating it once again with respect to x, we get a constant outside. Derivative of sine is cos ax plus b plus pi by 2. And into chain rule, differentiation of this term is a. Therefore, this a and that a, it becomes a square. Again, converting that cos in terms of sine, therefore it is a square sine of theta plus pi by 2 or pi by 2 plus theta. Therefore, here it is ax plus b plus pi by 2 plus theta. This is theta plus pi by 2. Therefore, we get this one. Therefore, simplifying it, we get a square sine of ax plus b plus 2 times pi by 2. Don't cancel it. If we see, for first we are getting a, for second we are getting a square. For y1, 1 times pi by 2. For y2 we are getting 2 times pi by 2. Therefore, if you differentiate it n times, we can write down results similarly. We get, it is a raised to n sine of ax plus b plus n times pi by 2. That is the required result. Okay. Exactly on the same line, I will derive the result for nth derivative of cos of ax plus b. Only change here, we are getting a term nth derivative of cos of ax plus b as a raised to n cos of ax plus b plus n times pi by 2. To obtain this result, consider y is equal to cos ax plus b, function of x, with a and b are constant term. Therefore, differentiating first time we get y1. Differentiation of cos is minus sine ax plus b. Chain rule. Differentiation of this term is a with respect to x. Rewriting this minus sine theta, all we know that it is cos theta plus pi by 2 or cos pi by 2 plus theta. Therefore, it is a times cos of ax plus b plus pi by 2. After conversion, we differentiate it second time. Therefore, y2 is equal to a constant. Differentiation of cos is once again minus sine ax plus b plus pi by 2. Chain rule. Differentiation of this term is a. Therefore, it becomes a square minus sine theta is nothing but cos of pi by 2 plus theta. Therefore, it is ax plus b plus pi by 2 and plus pi by 2. nothing but a square cos of ax plus b plus 2 times pi by 2. Therefore, for first we are having a, for second we are having a square, for third we have a cube like this, for nth we have a raised to n, and for pi by 2, for first derivative it is 1 times pi by 2, for second it is 2 times pi by 2. Therefore, if we differentiate it n times successively, we get that result as a raised to n cos of ax plus b plus n times pi by 2. Therefore, that is the required result. Therefore, remember just two important results to find out the nth derivative. Then I will present some examples on it, how we can apply these two results. First example, if y is equal to sine of 2x plus 3 as a function of x, sine as function of x, then find its nth derivative. Therefore, to obtain nth derivative, we use this result, standard result. Compare these two terms, we get a as coefficient of x, here it is 2, and b as 3. Therefore, taking nth derivative on both sides, we get nth derivative of y, and nth derivative of right hand side, it is sine of 2x plus 3. And then using this result, it is a raised to n, a is here 2, therefore we get 2 raised to n sine of ax plus b 2x plus 3 plus n times pi by 2. In one step, we are able to get the required result if we apply this standard result. Then second, if y is equal to cos of omega t plus alpha, find yn. Here y is function of t, y dependent variable, t independent, omega and alpha are constant term. Therefore, to obtain it, we use the second result. Therefore, yn is equal to, we get nth derivative of the term cos of omega t plus alpha. It is nothing but a raised to n. Here a means coefficient of t. It is omega raised to n cos of ax plus b, that is omega t plus alpha, and plus n times pi by 2. This is the required result. Again, in one step, we are able to get the result. Third example, if y is equal to sine square 3x, then find its nth derivative. We don't have the result for sine square. Therefore, first of all, we have to convert in this form. Therefore, we know that sine square theta as 1 minus cos of 2 theta by 2. So, using this result, I can rewrite that sine square 3x as 1 minus cos of 2 times 3x. 2 times 3x means it becomes cos of 6x and divided by 2. Then, taking nth derivative on both sides, it is nth derivative of sine square 3x, nth derivative of the right hand side term, it is 1 minus cos of 6x by 2. Here 1 by 2 constant term outside. Nth derivative of constant term is 0, and nth derivative of cos of ax plus b is a raised to n. Here a is 6 raised to n, cos of 6x plus n. This is minus 6 raised to n cos of 6x plus n times pi by 2 and divided by 2. Example number 4. If y is equal to sine cube of x, then find its nth derivative. Again, we don't have any formula for sine cube x directly for nth differentiation. Therefore, first of all, we try to use this result, a standard result. We know that sine cube theta as 1 by 4 times 3 sine x, 3 sine theta minus sine of 3 theta. Therefore, first of all, we convert this sine cube x using this result. Therefore, y is equal to sine cube x, nothing but 1 by 4 times 3 sine x minus sine of 3x. And then taking nth derivative on both sides, therefore, nth derivative of left hand side is yn, nth derivative of right hand side, there are two terms I will obtain separately, finding separately. Therefore, nth derivative of the first term becomes 3 by 4 sine of x minus 1 by 4 into this, therefore again 1 by 4 constant term outside. Nth derivative of the second term, it is sine of 3x. And then using this result, 3 by 4 outside, nth derivative of sine ax plus b, comparing here we get a as 1, therefore 1 raised to n, sine of ax plus b, sine of x only, and plus n times pi by 2, and minus 1 by 4, nth derivative of sine of 3x, it is a raised to n, a is here 3, therefore it is 3 raised to n sine of 3x plus n times pi by 2. And therefore, this is the required result. It is 3 by 4, 1 raised to n number we get 1, sine of x plus n pi by 2, minus 3 raised to n by 4, sine of 3x plus n times pi by 2 is the nth derivative of sine cube x. A last example, example number 5th. If y is equal to product of two terms, sine 4x into cos of 3x, then find its nth derivative. Nth derivative of this means it is not nth derivative of sine 4x into nth derivative of cos of 3x. We can't obtain like that. And therefore, first of all, we have to convert this product in terms of sum using defactorization. We know that two times sine A cos B as sine A plus B plus sine A minus B. We can apply this result. And to apply this, we have to multiply this by 2 and divide by 2, so that no change in the value, only I am changing the form. Therefore, that sine 4x into cos of 3x, nothing but y. I will multiply by 2 and divide by 2, so that no change in the value, only form is changed. And therefore, it is equals to 1 by 2 outside. 2 sine A cos B is nothing but sine A plus B, 4x plus 3x, we get sine of 7x, plus sine of A minus B, 4x minus 3x, we get x. And then I have converted this product in terms of sum using that defactorization. And then we can take nth derivative on both sides. Therefore, nth derivative of y is yn, 1 by 2 constant term. Nth derivative of that two terms, sine of 7x and plus sine of x. Finding nth derivative individually, therefore it is 1 by 2 sine ax plus b. Applying this result, it is a raised to n, a is here 7, therefore 7 raised to n sine of 7x plus n times pi by 2. Then nth derivative of the second term sin x is here 1. Therefore, it is 1 raised to n sin of ax plus b means x plus n times pi by 2. This is the required nth derivative. Therefore, I have discussed here 5 simple examples based on these two results how we can obtain the nth derivative of either sin x plus b or cos of x plus b. In third part, I will discuss another 2 important results for nth derivative. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thank you for watching.